So for the JEE 2025,
Yes.
the chemistry syllabus is having around 20 chapters.
Yes.
The first 8 chapters being physical chemistry,
Yes.
and second part up to
Inorganic chemistry.
13th up to 13th chapter inorganic chemistry, and 14 to 20 it is organic chemistry.
Yes.
So
So,
actually the chemistry is
yeah.
then
Yeah.
so branch of science that studies the composition, structure, properties and changes of matter,
Yeah.
including the interaction, the
Yeah,
relations
listen,
between
listen, I will
different
explain, you
substances.
just justify. Chemistry is the branch
Okay.
of that studies the composition, structure, properties, and changes of matter, including the interactions and reactions between different substances we are making in real time environment. There are a total of 118 confirmed elements in the periodic table we have seen in the real time environment. It starts from ranging from hydrogen element 1 to Agansen. Aganesen, the element last is 118. So the periodic table, whichever the element they are finding, it has to satisfy the some properties, some rules and regulations of that table they are inserting into the table. The father of chemistry is often regarded as Antoine Lavoisier, in the 18th century French chemist. He is a very famous scientist in chemistry. In modern terminology, we used to say he is the father of chemistry. Then there are broadly classified into three categories: organic chemistry, inorganic chemistry, physical chemistry. Organic chemistry deals with the carbon containing compounds, their properties, their structures, and their characteristics, their reactions, and followed by the structures. So, with the combination of carbon, we are performing all the real time applications. Then, coming to the inorganic chemistry, so in this chemistry, the study of inorganic compounds which typically do not contain, means there is no carbon in this in that substances, there in that composition, and it does not contain carbon hydrogen bonds. Such type of chemistry is called inorganic chemistry. And the third one is physical chemistry, the branch that deals with the physical principles. Suppose you are performing real time reactions in chemical reactions and performing various compositions and properties of matter in real time environment. Such type of chemistry is called physical chemistry. So there are among broadly classified elements, we have 8 types of chemistry. Analytical chemistry, it deals with the techniques and methods for analyzing substances to determine their composition and concentration. That is called analytical chemistry. And biochemistry starts with the study of chemical processes within the related to living organisms is called biochemistry. Then followed by the environmental chemistry, how in the environment situation as a human being, how we are digesting with such type of compositions and processes. The study of chemical processes occurring in the environment, maybe PFAS, maybe contaminants, maybe you can call it as a harmful elements that effects of human activities on these processes is called environmental chemistry. And followed by the seventh one is industrial chemistry. So by default you can expect so many contaminants from industry chemistry, the branch that applies chemical processes to the manufacturing industries releases. Manufacturing industries produces products on a large scale. There may be a waste of huge volume of PFAS, contaminants, and maybe in groundwater, in wastewater. There are many contaminants you can see in the industrial chemistry. Then followed by the theoretical chemistry. Here We are using mathematical model. Model is nothing but simplified version of the reality. In order to solve the real time applications, we are using simulations, maybe MATLAB, maybe Python, maybe you can use any tool to understand a chemical behavior in the predict chemical phenomenon. That is called theoretical chemistry. If you see, the periodic table is the heart of chemistry. We are organizing such a way that columns and rows having their own properties, their own characteristics, their own structures. Like columns, you can call it as a rows, we can call it as a periods, and columns we can call it as a groups or families with elements in the same group having similar behavior or properties. If you take first group, second group, third group, fourth group, likewise we have eighth group elements, and we have a lanthanide series and antonide series. We have various types of periodic table components. If you see in periodic table, we are arranging elements in a see, some sound is coming. Hello.
It's from your side only.
No, from my side, no disturbance. Okay. Periodic table is a symbolic representation of how easily we are arranging the elements based on the characteristics, based on the behavior structures, organized by increasing atomic number, electronic configurations, and recurring chemical properties, with elements in the same column group exhibiting similar behavior. So we have non-metals and metals in the group and periodic elements. Some elements are near dashed staircase, or some elements called metalloids, some elements called P block elements, some elements called D block elements, some elements called S block elements, F block elements. S block, see, you can call it as there are four types of block elements we have, with elements in the some elements group exhibiting similar behavior. Okay, then break into these sections of chemical chemistry, naturally divided into many sections like group elements. Like elements in the same group have similar properties is called row, columns is called groups, rows is called periods. That periods are nothing but elements in the same period having increasing atomic numbers, that is called rows. Blocks is nothing but we are dividing into SPDF. S means S block element spherical shape. P block is nothing but a dumbbell shape. D block elements is called a double dumbbell block structure, and F block is very complicated and a complicated structure, block based electronic configuration. That's why we are dividing into four groups of blocks like SPDF. Then focus on mastering each section separately. S block, P block, D block, F block. So S block contains group 1 elements, that is called alkali elements. You know very well what are the alkali metals and alkyne earth metals plus hydrogen and helium. Then P block is nothing but a dumbbell shape. The number starts from groups, that groups is called columns. Remember, groups is nothing but columns from starts from 13 to 18, including non-metals, metalloids, and some metals like any iron metals or any copper, any silicon, etc. Then D block elements is a double dumbbell shape. These metals are we used to call it as a transition metals. Like it starts from 3 to 12 elements. Then F block elements very complex in the periodic table, and lanthanides and anthonides in this group periodic table. Then what is the meaning of use mnemonics? Mnemonics is nothing but how easily we can remember 118 elements in the periodic table. There are some symbolic mnemonics devices to remember the elements in important groups, columns in the periodic table. So far, Antoine Lavoisier confirmed that 118 elements are there. You can call it as a group 1 elements alkali metals. What are the very shortcut form? Lena K. Roops CS feet. This is the shortcut of group 1 elements we can easily remember. Li stands for lithium and Na stands for sodium. K stands for potassium and RB stands for rubidium and CS stands for cesium and FR stands for francium. Then followed by the group 17 halogens. Halogens is nothing but so freaky clowns brought apples. You can call it as very simple shortcut form. Freaky clones brought ice apples. What is the short form of group 17 halogens? F stands for fluorine and Cl stands for chlorine, Br stands for bromine, I stands for iodine, and astatine stands for 80. These are the group 17 halogens elements. Then visualize the color coding. Suppose if you are unable to remember the columns and rows of the periodic table, at least you can remember with color. Use a color coded periodic table which consists of a number of rows and columns to identify different element categories like metals, non-metals, noble gases, inert gases. You can call it as transition metals. Colors help in visually grouping elements and enhancing memory retention. This is called how to visualize the with color coding of transition tables, transition table elements of 118 elements. Then group similar elements like that have similar chemical properties such as noble gases. Usually noble gases we used to call as colorless and another name of noble gases is called inert gases like helium, neon, AR and etc. And transition metals, we can call it as known for forming colorful compounds. You know very well about transition metals. We have already studied transition metals. Okay, so in these transition metals, by using colorful compounds, we can easily remember. Then, how do we can remember 118 elements to memorize key trends? Easy to remember by understanding the trends. Trends means latest elements of the 118 elements. Lavoisier, Antoine is invented this atomic radius, ionization energy, electronegativity makes recognizing elements positions easier. As you move across a period or down a group, these trends are predictable. And the last one is learn element symbols and names. Like easy to remember, Na means sodium, K means potassium, okay, and H means hydrogen, He means helium, Li means lithium. Like that, you need to remember from their Latin names, which can make remember them very easily in the real time environment. Okay, Mama, you can start now.
Okay. Chemical formula of any substance.
Yes,
So normally this nitrous oxide is a gas. We
yes,
call it as laughing gas.
yes.
So it is used as an anesthetic
N2O.
agent in
The
dentistry.
formula is
Nitrous
N2O.
oxide is a
Yes,
laughing gas.
yes,
It is used in dentistry and surgery due to its sedative and pain relieving properties.
correct.
That is one application. So gases are commonly used for cooking.
Yes,
That is liquefied petroleum gas, mainly composed of propane and isobutane. These are
yes,
the gases used for cooking because it burns cleanly, producing minimal pollutants when used safely. Because
yes,
these are all saturated hydrocarbons, lower saturated hydrocarbons.
correct.
So PFAS, per
PFAS.
and polyfluoroalkyl substances. These are persistent environmental pollutants that accumulate in water, soil, and human bodies, causing potential health risks like cancer and immune dysfunction. So that
Correct.
is the reason PFS play very important role in human health.
In real
Once
time
they're accumulated in
environment,
the body,
PFAS playing a vital role. We are identifying a number of contaminants in the groundwater,
so
wastewater, many things. Next.
so toxic elements
Yes.
like lead, mercury, cadmium, arsenic, these are harmful.
Cadmium analla. Cadmium.
Cadmium,
Yes. CD.
arsenic, chromium,
Yes.
these are all harmful because they can cause neurological, kidney, and cardiovascular damage when ingested or inhaled into the body.
Correct.
So, some elements are considered non toxic that are commonly found in everyday life,
Correct.
like carbon, hydrogen, oxygen, nitrogen are non toxic and form the basics for organic life and are found in water, air, and most living organisms. Most of the food materials contain these elements.
Correct.
So, there are like some gases called greenhouse gases,
Correct.
carbon dioxide, methane, water vapor,
Correct.
sometimes carbon monoxide also.
Hmm.
What they do is they trap the heat in the Earth's atmosphere,
Hmm.
leading to global
Hmm.
warming, and there will be a change in climatic conditions.
Hmm.
Commonly used found contaminants in drinking water
Hmm.
are arsenic, lead, and nitrate in drinking water.
Yes.
These cause serious health issues, including cancer, developmental disorders, and gastrointestinal problems. So the carbon monoxide, how it is dangerous to the home places, workplaces. It's a colorless, odorless, and highly toxic as it binds to hemoglobin more effectively than the oxygen, leading to carbon monoxide poisoning and potential fatalities. That means normally the function of the blood is to transfer the oxygen from one place to the other to all the cells. Instead of oxygen, if carbon dioxide is attached to the hemoglobin, so there will be lack of the oxygen for the metabolic reactions. That way it
Correct.
is a toxic element
Correct.
molecule. So there are some more toxic gases released during industrial process and how they are controlled is that so like sulfur dioxide, carbon monoxide, nitrogen oxides, and they're released from the industrials. Their emissions are controlled through scrubbers, filters, and regulation. Some separation techniques while they are living into the environment, we need to separate out them and put them aside
Correct.
so that it will not mix into the surrounding air or water.
Correct.
So the fertilizers, mainly the nitrates
Correct.
and phosphates, when they are used in large quantities, they lead to water contamination and eutrophication, causing dead zones in the aquatic ecosystem. Eutrophication means uh, when water contains nutritional elements, there some microorganisms will grow.
Yes.
So, the understanding the periodic table help in predicting element behavior. So, what is the main reason behind classification of the elements is that some properties, some characteristics of elements are periodically coming out. That means they will repeat out. So the periodic table allows to predict the chemical properties, reactivity of elements based on their group and period, trends like electronegativity, ionization energy, and atomic radius, etc.
Yes.
So for better understanding to remember,
Yes.
so periodic table is very much helpful. So when we are talking about the mass, the measurement of mass in terms of the moles is very important in reactions because the reactions happen between any reactants in a certain proportion. So those proportions are their mole numbers. So mole is a very important concept. 1 mole of any mass is equal to its molecular weight. We must remember 1 mole of a substance is equal to its molecular weight. That mole will have 6.023 into 10 power 23 molecules, or if it is an atom, 23 atoms.
That is called Avogadro number.
Avogadro number.
Yes.
So, the second law of thermodynamics states that energy tends to disperse, making perfect energy conversion impossible, which impacts the efficiency of engines, batteries, and other systems. For example, one glass is full of water is there. Is
Yes.
it possible to remove 100% water from that glass?
No.
At least some 0.0001 percent will be left over. Like this, energy is there. That energy, all energy cannot be converted into other form.
Yes.
That is one form of the second law of the one type of the second law of thermodynamic statement. So the chemical bonding play an in determining the physical properties of the substance. If the chemical bonding is more, bond energy is more, the intraatomic forces will be more. So there are chemical bonds like ionic bond, covalent bond, metallic bonds that determine the substance melting point, solubility, conductivity, hardness, and their applications in everyday materials like that. So the bond between interatomic molecules, interatomic atoms will determine these properties. So accordingly, we make use of their utilization. So why is the understanding of redox reactions essential in environmental chemistry is redox reactions are crucial in environmental process like water purification, corrosion, and the breakdown of pollutants, helping to solve key ecological challenges. So that is the reason in environmental chemistry, understanding of these redox reactions is
Ecological
important.
challenges like birds, living organisms, anything. No? Ecological means related to birds, environment.
Ecological means environment is different.
Yes.
Ecologically means a place where all living organisms are
Yes. Correct.
interacting with the non-living.
Correct.
There, an
Correct.
interaction between living and non-living organisms
Is
in a
called
certain environment is called as ecology,
ecological
ecosystem.
yes. How do we catalyst?
Catalyze.
Ah,
What is that?
yeah. How do you catalyze catalyst rates without being consumed? Catalyst lower the activation energy of a reaction.
Wait.
Yeah, it is not
Catalysts
used.
increase the reaction rates without being consumed.
Correct.
So, say for example, if you are walking on a normal road freely without any support, you can go.
Yes.
Suppose if you are moving in a dirty area, బురద అట్లా ఉంటుంది అనుకో, for example.
Mm, mm,
So you need to be very careful, otherwise you will slip down.
mm.
So this catalyst acts as a good platform for interacting reacting molecules to produce the products
Correct.
by decreasing the activation energy.
Mm.
So in summer we need for 4 liters of water per day, for example.
Yes.
In winter also,
Mm.
will you take that much? Even if you take, it will be overthrown. So like that,
Yes.
by by decreasing the activation energy, it acts as a support for the reactions to proceed. So
Yes.
many catalysts are there, industrial use.
Correct.
So when reactions are happening normally in, especially the biochemical reactions,
Mm.
there will be change in pH. pH is nothing but negative log of concentration of hydrogen ion.
Yes.
So that will be between 1 to 14. 7 indicates neutral.
Ah.
Less than 7 indicates acidic. More than 7 indicates alkali.
Yes.
So when there is a change in pH, there will be change in all other biological systems, especially the reactions will change.
Correct.
Suppose if any organism is there at under certain pH range, it will not survive like that. So levels of pH maintaining is very important for the stability in biological process.
Correct.
That's an important parameter.
Yes.
So how is the concept of equilibrium applied in industrial chemical reactions? Normally, a reactant is giving some product, or two reactants are giving some product, A plus B giving some product R. It comes to an equilibrium condition
Yes.
after a long time
Yeah.
where that reaction system possesses lowest possible energy.
Yes.
And the energy is more, forward reaction will be more.
Yes.
Continuously, all the reactant will not be converted to product. At a
Yeah.
certain extent where the system attains lowest energy level, backward reaction will also take place. The forward reaction and backward reaction at certain instant at a given temperature and pressure with given catalyst remains constant. Such a condition is called as chemical equilibrium.
Correct.
So these are very important in industrial process. So
Yes.
what maximum conversion is possible at a given temperature and pressure. So
Yes.
according to that, we need to take some actions in industrial to maximize the product
Yes.
like that. So these transition elements important catalysis in material science. Why it
Yes.
is because they have variable oxidation states. Oxidation state is nothing but number of electrons that it can share while forming a reaction.
Yes.
So variable oxidation states it can produce and ability to form complex compounds. It may form complex compound and play a critical role in catalysis because of its crystalline structure being their metals, they'll support as catalysts and the development of strong durable materials. And the study of organic chemistry contribute to the pharmaceuticals and healthcare. How it is organic chemistry is essential for designing and synthesizing drugs. Mainly for all diseases, we need to use some medicine. So medicine is nothing but a combination of different molecules. Those molecules are called as drugs. So understanding the biochemical pathways and developing new treatments for diseases impacting the global healthcare significantly, these pharmaceutical and healthcare are interrelated. So Dalton atomic theory and why it is fundamental to chemistry is that proposes that atoms are indivisible. Atoms cannot be subdivided
Correct.
and they combine to form compounds, laying foundation for modern chemistry. One element is there, another element is there. These two elements, like or unlike elements, will form some molecule. Those
Correct.
molecules, with some other molecules, may form some other compound. Like that, Dalton atomic theory proposes that atoms are indivisible; they cannot be divided, and they may form some bond with other like or unlike atoms, and they form some compounds. So then photoelectric effect shows that light consists of particles which can eject electrons from a metal surface when striking it. So when there is a metal, if you allow a light to pass on that, some electrons will come out. That is photoelectric effect.
Correct.
And what is the significance of Parsons rule in predicting bond character? Parsons rule helps predict whether a bond will be more ionic or covalent based on the size and change of charge of the ions involved.
Correct.
The more the bond energy, more will be the less will be the size, like that. So how does the first law of thermodynamics apply to energy conservation in chemical reactions? The first law of thermodynamics states that the energy cannot be created or destroyed, only can be transferred from one form to the other form. Mainly in the first law of thermodynamics, it is the equivalence relation between the work and heat. So based on the law of conservation of energy, the first law of thermodynamics is developed. Raoult's law. Raoult's law explains how the vapor pressure of a solution changes based on the concentration of the solute in the liquid. So it is essential for understanding the colligative properties. Colligative properties means when the solute is added to the solvent, some properties will be there.
Correct.
So those properties are called as colligative properties. So what role do catalyst play in a chemical reaction according to chemical kinetics? Catalyst lowers the activation energy of a reaction, speeding up the process without being consumed. It will not be used in the reaction, but it acts as a platform without participating in the reaction. So, how does the periodic trend of electronegativity affect bond formation? Electronegativity differences between the elements determine whether a bond will be ionic or covalent, affecting the properties of the
Yes.
compound. The role of coordinate compounds in biological system. Coordination compounds such as hemoglobin are crucial for biological process like oxygen transport in blood. Coordination compound means one atom will be bounded with
Ah,
different ligands, like this attachment.
yes.
So hemoglobin, what it does, it takes uh,
Hemoglobin.
uh,
Hemoglobin కాదు hemoglobin. Yeah.
hemoglobin. Okay, so that gives some space to oxygen to
Correct.
adsorb on the surface, and it carries along with that. So that way it is helpful. So these colligative properties like boiling point elevation. So normally liquid is there, its boiling point will be something. If
Yes.
solute is added, its boiling point will be elevated, increased.
Yes.
Or sometimes uh, its freezing point will be decreased. Like
Yes.
that, colligative properties will be there. So Nernst equation is crucial in electrochemistry, which relates the cell potential to ion concentration, helping calculate the voltage of electrochemical cells in various conditions.
Yes.
Electrochemistry and will come across the Nernst equation.
Yes.
These all already know. Matter is nothing but something that occupies space and having some mass. It may be existing in solid, liquid, or gaseous form. This
Correct.
Galton atomic theory says all matter is made of individual atoms which combine to form molecules and compounds.
Correct.
The mole concept already we have discussed. This is a repeated question.
Yeah.
The law of chemical combination. The law of chemical combination includes the laws of conservation of mass. That means mass cannot be derived or destroyed or created. And law of definite proportions. Suppose the molecule at atom A and atom B is giving some product C. So how many proportions? 1 mole of A, 2 moles of B, giving 3 moles of C, like that.
Yes.
And the same reaction may happen. 1 mole of A plus 1 mole of B gives some other product R.
Yes.
So definite proportions will be there. Multiple proportions also will be there. So these will govern how substances combine to form compounds. These are the laws of chemical combination. Where the chemicals combination reactions are happening, that way it happens. So Heisenberg uncertainty. Electron will be revolving around the nucleus in a certain path called orbital. While it is rotating around, revolving around the nucleus, simultaneously it is not possible to find the exact position and momentum of an electron. Either you can find out the position or you can find out the momentum. Simultaneously, it's not possible. That is uncertainty principle. The significance of molecular orbital theory. So, molecular orbital theory explains how atomic orbitals combine to form molecular orbitals. Two atoms may form one molecule. So, how that molecules have orbitals? If it is single atom, when electrons are there, they will be around revolving around the nucleus in a certain path. Those are called as orbitals. When these atoms form one molecule, so hybridized orbitals will be formed, which describes the bonding, anti-bonding interactions, and the overall electronic structure of those molecules. Second law of thermodynamics states that the entropy or disorderedness or randomness of an isolated system always increases in a spontaneous process governing the direction of chemical reactions. So it will be the single direction, not reverse direction. So Raoult's law again it states that the vapor pressure of the solvent in a solution decreases in proportion to the mole fraction of the solute particles added to it. So the more the concentration, the more will be the vapor pressure, like that. Lee circular principle for equilibrium conditions predicts that when a system at equilibrium is disturbed, it will shift to the one direction that minimize the disturbance to restore the equilibrium again. So when there is already equilibrium condition, if you disturb that, again some condition equilibrium will come. According to that, the shift will be taking place to minimize the disturbance. So next equation used for
Cell potential.
electrochemistry.
Yes.
So it relates the cell potential of an electrochemical cell to the concentration of the reacting ions, allowing for the calculation of cell voltage under non-standard conditions. So that is the next equation. So what is the significance of the half-life in chemical kinetics is half-life of a reaction is the time required for half of the reactants to be converted into products. This is very crucial for understanding the reaction rates and mechanism. Say for example, 100 grams you are taking, how much time it takes to produce, to convert 50 grams into products. That is half-life. Lanthanide contraction and why it is important. The lanthanide contraction refers to the gradual decrease in the atomic and ionic radius of the lanthanides, affecting the properties of subsequent elements in the periodic table. From left to right, the periodic table along horizontal direction, some contraction will take place, which gradual decrease in the atomic size and atomic radius. That is lanthanide contraction.
Cannizzaro reaction.
This reaction involves the base individual disproportionation of aldehydes lacking alpha hydrogen atoms, producing an alcohol and carboxylate salt. Base individual disproportion of aldehydes lacking alpha hydrogen atoms, producing an alcohol. Aldehyde is CHO. It becomes OH. That is a Keynesian reaction. HO, C, one side H bond and one double bond O. That becomes COH. So that is Keynesian reaction. Aldehyde groups convert to alcohol and carboxylate salts. The significance of the Heisenberg uncertainty principle states that already we have seen impossible to precisely measure both the position and momentum of an electron simultaneously, meaning the more accurately one is known, the less accurately the other can be determined. Valence shell electron pair repulsion theory. It predicts that the shape of molecules by assuming that electron pairs around a central atom will arrange themselves to minimize the repulsion, resulting in specific molecular geometries like linear, trigonal, planar, tetrahedral, like that. So that's why that structure of the geometries of compounds happens is because of the valency shell electron pair repulsions. Electrons are there. Electrons are like charges. There will be repulsion between any two electrons. The resultant force will cause to the specific molecular geometries like linear, like that.
Yeah.
The
Trigonal,
the shape
planar, and
of molecule,
tetrahedral. Yeah.
the shape of molecules is because of the valence shell electron pair repulsion.
Correct.
Why this why this molecule is like this, why this molecule is like this in its structure is because of the valence shell electron pair repulsion
Correct.
condition. These are all duplications only.
Yeah. There are 20 chapters, important for each chapter. 3 to 5 important concepts I am going to explain. Please explain. What is the nature of matter?
So matter we know occupies space and has mass, existing in solid and liquid or gaseous state. These are all many of the times we have discussed it. Na? Instead of that, better do some exercise somewhere.
No problem. Continue. Dalton's atomic theory states that all matter is
All matter is made of individual atoms that combine to form the products.
correct.
The laws of chemical combination, including the law of definite proportions, govern how elements combine to form compounds.
Correct.
The mole concept defines as 6.023 to 10 power 23 particles, the number of atoms in 12 grams of carbon 12.
Yes.
Or mole is nothing but its molecular weight.
Yes. That is correct answer. Precise answer. What is the
In
stoichiometry in chemical equations?
stoichiometry, the quantities of it is the quantities of the reactants products in a reaction in a balanced equation. How many number of moles of A, how many number of moles of B, how many number of moles of C, like that.
Yeah.
So it is it gives the proportion among the reactants and products.
That is called the chemical equations of stoichiometry. Then
Yes,
atomic
it's
structure.
balanced equation.
Yeah. What is the
Photoelectric effect, already we have seen that the emission of electrons from a metal surface when it light strikes it. Bohr model of the hydrogen atom explains that electrons orbit the nucleus in a quantized energy levels, emitting or absorbing energy when transition between the levels from lower level to higher level. If it has to go, it takes some energy. If it comes from higher level to lower level, it leaves some energy. That is absorption and emission of the energies. De Broglie relationship states that matter has both wave-like and particle-like properties described by the wavelength lambda is equal to h by mv. H is the Planck's constant, mv is the momentum. The Heisenberg uncertainty principle already we have seen. Wait. Above principle states that the electrons fill the lowest available energy orbitals first before filling the higher ones. There is a rule, that is a principle.
chemical bond?
When other electrons are coming and filling into the atom, they will be filled in lower energy levels in order of the energy levels. So ionic bonding occurs when electrons are transferred between atoms, creating oppositely charged ions that attract each other. That is the biggest, strongest bond. Covalent bonding involves the sharing of electrons between atoms to achieve a stable configuration. Then valence is electron
Pair repulsion.
pair theory. It predicts that the shapes of molecules based on the repulsion between the electron pairs in the valence cell. So the concept of hybridization is the mixing of atomic orbitals to form a new hybrid orbitals that explain molecular shapes and bonds. So what is hydrogen bonding? Hydrogen bonding is a strong intermolecular force where hydrogen is attached to a highly electronegative atoms like oxygen or nitrogen or all pre-black elements also. Pre-black elements, especially these halogens,
Halogen.
they're all electronegative elements. First law of thermodynamics states that the energy cannot be created or destroyed, only they can be transferred from one to other. Mostly heat to work to heat.
Yes.
Entropy is a measure of disorderness or randomness in a system, increasing in spontaneous process. Spontaneous means without any involvement, external involvement. So gives free energy determines the spontaneity of a process where a negative delta G indicates a spontaneous process. So free energy of a system, if that value is negative, then only it's a spontaneous reaction. Hess law, when a reaction is happening in multiple reactions, A plus B giving some product R, that is the overall reaction. So in
Yes.
between there may be different reactions, A plus B giving AB, and AB plus B gives AB2, AB2 plus A gives 2AB, and then last law R, like that. So all together, if you add the energies, the enthalpy changes, energy means the enthalpy change of that reaction, regardless of the pathway, both will be same.
Yes. That is called
Whether
Hess
a
law.
reaction takes place, when a reaction takes place in a single step or in multiple steps, total enthalpy change is same. So the second law of thermodynamics states that entropy of an isolated system always increases in a spontaneous process. That also we know. Molality, the concentration of a solution, expressed as the number of moles of solute per kilogram of the solvent. So solute is the component that dissolves in a solvent. That will be in less quantity. So solute per kilogram, moles of solute per kilogram of solvent. And colligative properties are boiling point elevation, freezing point depression, and osmotic pressure. The Raoult's states that the vapor pressure of a solvent in a solution decreases as the mole fraction of the solute increases. Raoult's states the vapor pressure of a solvent in a solution decreases as the mole fraction of the solute increases.
Raoult's law.
I doubt it.
Yeah. Vapor pressure of a solvent in a solution decreases as the mole fraction of the solute increases. That is called Raoult's law. Then Wand's half factor.
So Vanda factor accounts for the effect of solute ionization in a colligative property. It gives some value.
Equilibrium.
Solute, when solute is there, whether it is become, suppose sodium chloride is there, sodium chloride can become Na plus Cl minus ionization. So like that, the effect of that solute in ionization colligative properties that accounts for Van half factor.
Correct.
Dynamic equilibrium occurs when the rate of the reaction, forward reaction and reverse reaction are equal with no net change in the reactant or product concentration. That's called as a steady state dynamic equilibrium. Le Clear principle states that a system at equilibrium will shift to counteract a disturbance in concentration, pressure, or temperature. When there is change in these parameters, it will move towards another direction to establish equilibrium again. So the common ion effect refers to the decrease in the solubility of a compound when the solution already contains one of its ions, like that. Buffer solution resists changes in pH when small amounts of acid and base are added, maintaining a stable pH. That means pH can be maintained almost constant. That's called as a buffer solution. Redox reactions and electrochemistry. Oxidation is the loss of electrons during a chemical reaction. Reduction is the gain of electrons during a chemical. This is the modern definition. In modern days, there are so many definitions are there. So modern definition of the oxidation is loss of electron. For
Yes.
reduction, it is gain of electrons. What is an electrochemical cell? An electrochemical cell converts the chemical energy into electrical energy through redox reactions. That is, for example, when you see battery,
Yes. Yeah. Battery.
Kohler's law. It states that the limiting molar conductivity of an electrolyte is the sum of the individual contributions of its ions.
Yes.
The rate of a chemical reaction is the change in the concentration of a reactant or product per unit time. That
Yes.
way we define. Arrhenius equation describes how reaction rates increase with temperature relating to the rate constant and activation energy and its temperature. K is equal to K naught e power minus E by RT. K is the rate constant, K naught is the frequency factor, E power minus E, that E is the activation energy, by RT, that is absolute temperature. So activation energy is the nothing but the minimum energy that is required for the reactants to undergo a chemical reaction to form the product.
Up to
So
8
inorganic,
chapters are physical
mm,
chemistry. Now I am going to
yes.
start inorganic chemistry. Okay, explain. Unit 9, classification of elements.
Classification of elements and periodicity and properties. Why these are all, again, so many times we have discussed
No,
it now,
no, no,
sir.
no. Please explain. Yeah, what is the modern periodic law? The modern.
Modern periodic law states that the properties of elements are periodic functions of their atomic numbers.
Correct.
So as the atomic number will increase certain after certain extent, the
Yes.
properties will be repeated.
Yes.
And the latest another concept is that modern periodical table states that the properties of the elements
Hmm.
are periodic functions of their atomic numbers. Instead of that,
Hmm.
it's more convenient and comfortable to talk that as periodic functions of their electronic configurations. That is the
Ah.
most suitable.
Oh, yeah, correct. Next.
So enthalpy change. When ionization enthalpy is the energy required to remove an electron from an atom in its gaseous state. What is called as ionization energy. And P black elements. What are the general trends in P black elements is they show trends in electronegativity, ionization energy, reactivity across periods and groups. D and F black elements, they are called as transition elements. These are D black elements characterized by variable oxidation states, colored compounds, and catalytic activity. The coordination compounds consist of a central metal atom or an ion bonded to surrounding ligands forming a complex ion.
Correct.
So purification. Chromatography is one of the separation techniques that separates the compounds based on their movement through a stationary phase. That is like a selective absorption. Just like a bus is going, school bus is going. So at their own places, students will be getting down.
Yes.
Like that, if any components that are present in a solution, while it is passing through our stationary phase, respective places there will be separation. That
Correct.
is called as a chromatographic separation. Some basic principles of organic chemistry is the inductive effect.
Correct.
Inductive effect is the shifting of an electron density along a chain of atoms in response to electronegative atoms or groups.
Correct.
Electrons density means clump of electrons will be there.
Correct.
So there will be a shift in this chain of atoms. Resonance in organic chemistry is bond, double bond or single bond will be electrons will be moving across.
Correct.
Delocalization of the electrons across multiple atoms, stabilizing the molecule, just like benzene. You just Google it, physical phenomena of electron across the multiple atoms in benzene molecule.
Yes.
You see that
Okay. Next, what are transition elements? My
hydrocarbons.
Yeah. My screen is
Gem-
visible. What are transition elements? Yeah. Unit 11.
next slide we are going now.
Yeah.
This slide is also over.
Purification also over.
Uh,
Next. Yeah.
Hydrocarbons 37.
Yeah.
What is geometrical isomerism in alkenes? Geometrical isomerism occurs when alkenes have different spatial arrangements of groups around a double bond like cis and trans forms, left, right. Suppose optical isomers, for example, if you see your face in
Yeah.
a mirror, one is cis, other is trans.
Correct.
Image, mirror image.
Yes.
Like like that, there will be isomers. They are called as isometric isomers, geometrical isomers, containing halogens. The environmental effects of DDT and freons. DDT, dichloro-diphenyl trichloroethane, is a toxic wildlife, while freons contribute to ozone layer depletion. DDT and
Dichloro,
freon,
diphenyl, trichloroethane.
ethane.
Yeah. Today I
Freons means
have updated. Today I have updated this thing.
dichloroethane.
Yes.
Freon,
Yeah. Is toxic to
organic
our.
compound containing oxygen.
Yes.
So Remer-Tiemann reaction forms a phenolic aldehydes by
Yes.
reacting phenols with the chloroform to the presence of base.
Yes.
Phenolic aldehyde means cyclic compounds. For
Yes.
that alcohol group that is called phenolic aldehyde, CHO group.
Yes.
Aldehyde means CHO, that is a functional group.
Yes.
Ring compounds ki aldehyde unte that reacts with phenols with chloroform in the presence of the base. That is
Correct.
the Remer-Tiemann reaction.
Remer.
Organic compounds containing nitrogen.
Yes.
Diazonium salts are organic compounds used in synthesis of dyes involving nitrogen cations bound to an aryl or alkyl group. Aryl group means cyclic group, alkyl means open chain.
Correct.
So, what are carbohydrates?
Mm.
They are the organic molecules composed of carbon, hydrogen, and oxygen, serving as energy sources and structural components. Mainly glucose, mainly glucose. The principles related to practical chemistry is more salt. It's a double salt of ferrous sulfate and aluminum sulfate used in redox reactions. The principle behind the enthalpy of neutralization is the enthalpy of neutralization is the heat change that occurs when an acid and a base react to form water, typically releasing energy as heat in an exothermic reaction. That is called as the enthalpy of neutralization.
Correct.
Again, the same.
Yeah. Matter and its nature.
So many times it will talk.
Yeah. No
We have
problem.
discussed it.
Yeah. Up to 74 will go. Yeah. That occupies space and has mass.
Wait.
We are in recording, please.
Record is not that necessary. So matter is anything that occupies space and has mass classified into solids, liquids, and gases. That
Correct.
already we know.
Yes.
And Dalton atomic theory proposes that atoms are individual particles that form a basis of. Please wait, sir. Stop recording.
No, no, no. I can't. If I stop, everything will go, sir. I am uploading in the YouTube channel, sir. Please. Next.
Just
Yeah. Laws
చెప్పు.
of chemical combination.
These laws are govern the ways
Yeah.
elements combine to form the compounds, including the law of conservation of mass, law of definite proportions. So the atomic masses
And molecular masses.
or molecular masses is the sum of the
Weighted average mass.
in a molecule. That
Correct.
means when a molecule is there, it's sum of the individual atoms mass.
Hmm.
So mole and molar mass. Mole is the quantity of substance containing as many entities as atoms in 12 grams of carbon, and molar mass is the mass of 1 mole of a substance.
Substance.
In other words, you can say 1 mole is the quantity equal to its molecular weight expressed in grams or kgs.
Correct.
The mass percentage of each element in a compound when two or more compounds are mixed, that is mass percentage. And empirical formula and molecular formula are related in such a way that the whole number ratios of atoms in a compound. Molecular formula shows that actual number of atoms.
Correct.
And chemical equations and stoichiometry, they represent the reactions and the quantitative relationships between reactants and the products. That is the proportion among the reactant products, in other words. So electromagnetic waves like light that travel at the speed of light and exhibit wave particle duality. That is electromagnetic radiation. So emission of electrons from a metal when exposed to light, illustrating the particle nature of the light, is called as photoelectric effect. Bohr model of hydrogen atom, a model where electrons revolve in a fixed orbits with energy levels quantized. So dual nature of the matter, matter exhibits both wave-like and particle-like behavior as explained by de Broglie's hypothesis. Then it's impossible to simultaneously know the exact position and momentum of an electron. This is Heisenberg uncertainty principle. So quantum mechanical model of an atom describes electrons as wave functions in orbitals with specific quantum numbers defining them, their energy and shape. The rules like Abbo rule, Pauli's rule, and Hund's rule, they guide the arrangement of electrons in orbitals, emphasizing the energy levels, exclusion, and maximum multiplicity. Electrostatic attraction between positively and negatively charged ions,
It's
it is
called
an
ionic bond.
ionic bond. In the covalent bond, sharing of the electrons between atoms to achieve a stable configuration. The lattice enthalpy, it is the energy released when gaseous ions form a solid ionic lattice. Then VSEPR, valence shell electron pair repulsion theory predicts the shape of the molecules based on repulsion between electron pairs in the valence shell. Then valency bond theory and hybridization. Covalent bonds formed by overlapping atomic orbitals, and hybridization involves mixing sp and d orbitals.
Molecular orbits.
Molecular orbital theory describes bonding in molecules through molecular orbitals formed by the combination of the atomic orbitals. So only the theory that explains orbitals in fact is for atoms. When
Yes.
these atoms are giving some molecules, they are called molecular orbitals. They are not. They will have complex in their shape. So a bond formed by the decolorized sharing of electrons in a metal lattice is called as the metallic bond. The study of energy changes, especially relation between heat, work, and internal energy in the systems, is explained in thermodynamics.
Yes.
The first law of thermodynamics says that energy cannot be created or destroyed, only can be converted from one form to the other, that too from heat to energy, work, or work to heat. The second law of thermodynamics states that the entropy of an isolated system always increased in a spontaneous process. Gibbs free energy is nothing but the energy associated with a chemical reaction that can be used to do work, where negative values indicate the spontaneous reactions. The Raoult's law states that vapor pressure of an atom, an ideal solution, depends on the vapor pressure of each component and its mole fraction in the liquid.
Yes.
The colligative properties that depend upon the number of solid particles in a solution, such as boiling point elevation, freezing point elevation, osmotic pressure, are called colligative properties.
Correct. Correct.
Dynamic, the dynamic equilibrium is a state where the forward and backward reactions are equal,
Occur.
maintaining the constant concentrations of
Yeah. Occur at equal rates. Yeah.
reactants and products.
Correct.
Le principle says that a system at equilibrium will adjust to counteract any applied stress. Reactions involving the transfer of electrons, where one species is oxidized, the other is reduced. That is called as redox reaction. So, the electrochemical cell is a device that converts chemical energy into electrical energy with galvanic cells generating spontaneous electricity. Nernst equation it relates the cell potential to concentration, temperature, and pressure in electrochemical cells. The rate of reaction is defined as the change in the concentration of reactant or product per unit time affected by factors such as temperature and concentration. The Arrhenius equation describes how reaction rates increase with the temperature due to the exponential increase in the rate constant. A is equal to A naught T power minus E by RT, like that. Exponential decay. The trends in elements properties such as atomic radius, ionization energy, and electronegativity across periods and groups in the periodic table will change. D and F black elements are called transition metals, known for favorable oxidation states and for their catalytic properties and the formation of colored compounds. The coordination compounds are the complex compounds where central metal ions bond to surrounding ligands with important applications, biological systems, and industries. The purification of organic compounds is done through methods like distillation, chromatography used to separate and identify the compounds. Isomerism is a phenomenon where compounds have the same molecular formula but different structures leading to different properties. Hydrocarbons are the organic compounds consisting of hydrogen and carbon, including alkanes, alkenes, alkynes, and aromatic compounds. Carbon, hydrogen, open chain compounds are closed chain compounds. Aromatic means closed chain, circular shape. Then alcohols and phenols, organic compounds containing hydroxyl groups showing different reactivities and uses. Amines, organic compounds containing nitrogen, classified as primary, secondary, or tertiary based on the number of alkyl groups attached to the nitrogen. Carbohydrates, proteins, and nucleic acids, these are the biomolecules essential for life, involved in energy storage, structural functions, and genetic information. Titrimetric analysis are the quantitative chemical analysis methods involving the measurement of titrant volume to react with an analyte. The laws of chemical combination, these are the fundamental principles governing the ways in which the chemical elements combine to form compounds such as law of definite proportions. Atomic and molecular masses. Atomic mass is the average mass of an element's atom, while molecular mass is the total mass of all atoms in a molecule. The empirical formula shows that the simplest ratio of elements to in a compound, while the molecular formula indicates the actual number of atoms. The chemical equation is stoichiometry. Chemical equation represents a chemical reaction and stoichiometry involves calculating the quantities of reactants and products. The variation in psi and psi square for 1s and 2s orbital describes how the wave function and probability density of an electron vary with the distance from the nucleus in 1s and 2s orbitals. Psi is the wave function and psi square is the probability density function. Electron spin and spin quantum number. Electron spin is a fundamental property with the spin quantum number indicating the direction of electron spin. Fason's rule predicts whether a bond will be more covalent or ionic based on the charge and the size of the ions. Dipole moment is a measure of the separation of charge in a molecule, indicating polarity. That means when there is a molecule, so partial negative charge one side, partial positive charge one side, they will distribute. That is called as polarity. So dipole moment is one such measure of a separation of the charge in the molecule. So resonance in chemical bonding refers to the delocalization of the electrons across the multiple structures, stabilizing the molecules. Then bond order, bond length, and bond energy. Bond order is the number of electrons bonds to between two atoms, while the bond length and bond energy describe the distance and strength of these bonds. Hydrogen bonding is a strong intermolecular bond where a hydrogen atom is attached to an electronegative element in another molecule. It's important in water properties. So, for being water in the liquid state that is the reason it is in the liquid state.
Correct.
The system and surroundings in a thermodynamics. The system is the part of the universe being studied, which is under observation, while the surroundings is include everything else other than the system. So entropy is a measure of disorderedness or randomness in a system related to the second law of thermodynamics. Enthalpies of combustion and formation. The enthalpy of combustion is the heat released during the combustion of substance, while enthalpy of formation is the heat of change when a compound forms from its elements. The equilibrium constants K based on the concentrations and pressures are different. Kp is the equilibrium constant for gases in terms of the partial pressures, and Kc is the constant in terms of the concentrations. Ionization of water at pH scale. Water self-ionizes to produce H plus and OH minus ions, and pH measures the acidity or basicity of a solution. So, common ion effect, the shift in equilibrium caused by adding an ion already present in the solution that affects the solubility and ionization. Then electrolytic and metallic conduction. Electrolytic conduction occurs through ions in a solution, while metallic conduction happens via electrons in a metal. Cell potential and gives energy change. The potential difference of a cell relates to the free energy of change of the electrochemical reactions. Then collision theory of gaseous reactions, it states that the reactions occur when particles collide with sufficient energy and the correct orientation. Law of periodic properties, elements show the periodic trends and properties such as electronegativity and atomic size across the periodic table. Lanthanide contraction, the gradual decrease in the size of lanthanide atoms due to the poor shielding of f orbitals. Werner theory of coordination compounds describes how metal atoms bond with surrounding ligands in complex ions. Crystallization is a purification process where a solid forms from a liquid or gas, separating it from the impurities. Qualitative analysis in organic chemistry. These are the techniques to detect elements like nitrogen, sulfur, halogens in organic compounds. Tetravalence of the carbon. So carbon forms four covalent bonds, enabling it to create a wide variety of organic compounds. Free radicals, carbocations and carbanions. These are the reactive species in organic chemistry where atoms or molecules possess unpaired electrons, positive charges or negative charges. And hyperconjugation, delocalization of electrons in a molecule that stabilizes carbocations and contributes to the structure of organic molecules. Then geometrical isomerism, a type of stereoisomerism where molecules with the same connectivity differ in the spatial arrangement of atoms around a double bond. Then polymerization of alkenes and alkynes, chemical reactions where small monomer compounds join to form the larger polymers like plastics. Electrophilic substitution in aromatic compounds, a reaction where electrophile replaces a hydrogen atom in an aromatic compound like benzene, that is called electrophilic substitution. In place of hydrogen, one electrophile will come. Electrophile means electron loving. Substitution reactions in halogen compounds. Halogen compounds undergo nucleophilic substitution where a halogen atom is replaced by another group. Riemann-Tiemann equation is a chemical reaction used to form phenolic aldehydes from phenols. Grignard reagent, it's an organomagnesium compound used to form carbon-carbon bonds in organic synthesis. Diazonium salts, these are the organic compounds used as intermediates in the synthesis of dyes and other chemicals.
Aldol.
Aldol condensation, it's a reaction between aldehydes and ketones to form a larger beta hydroxycarbonyl compounds. These are important in organic synthesis. Nucleic acids, DNA and RNA, these are the molecules responsible for storing and transmitting genetic information in living organisms. Vitamins, these are the organic compounds required in small quantities for essential biochemical reactions in the
Body.
body. Hormones, chemical messengers produced by endocrine glands that regulate various physiological processes in living organisms. Hormonal imbalances will cause diseases. So, balancing of the hormones has to be there in any living organisms. Preparation of inorganic and organic compounds. There are methods to synthesize compounds such as more salt and acetanilide in laboratory. Qualitative salt analysis. It is the process of identifying cations and anions in a sample based on their chemical reactivity. The kinetic study of the reactions is nothing but the study of reaction rates and a mechanism to understand how reactants transform into products. Then the calculation of the empirical molecular formulae, it determines the simplest ratio and actual number of atoms in a compound based on the experimental data. The Van Hoff factor, it's a measure of effect of solutes on the colligative properties, correcting for ionization or association in solutions. Then hydrolysis of salts and pH of solutions. The process in which salts react in water to produce acidic or basic solutions with the pH determined by the nature of the ions.
Solubility
The
product.
soluble product, the equilibrium constant for the dissolution of a sparingly soluble salt predicts solubility under various conditions. The buffer solutions, these are the solutions that resist changes in pH when small amounts of acid or base are added, made of weak acids and bases in their salts. Kohlrausch law, it states that the limiting molar conductivity of an electrolyte is the sum of the individual contributions of its ions. So next equation is a formula that relates the electromotive force of a cell to the concentration of the reacting ions used in electrochemical cell calculations. Then lead accumulator, a rechargeable battery made of lead electrodes in a sulfuric acid solution, widely used in vehicles as battery.
Correct. Fuel cells.
The fuel cells, electrochemical cells that convert a chemical energy from fuel into electrical energy through a redox reaction, offering efficient power generation. Arrhenius theory explains the effect of temperature and reaction rates, proposing that molecules must collide with sufficient energy to react. The activation energy is the minimum energy required for reactants to form the products in a chemical reaction as described in the Arrhenius equation. The time required for half of the reactants in a reaction to be consumed is important in chemical reactions, that is called as half-life. So catalytic behavior of the transition elements exhibit because of catalytic properties due to their ability to change oxidation states and form complexes. Lanthanide contraction. It's a phenomenon in which atomic radii of the lanthanide decreases across the series, affecting the properties of subsequent elements. Coordination number refers to the number of ligands bound to a central atom in a coordination compound, affecting its geometry and reactivity. Then denticity and chelation. Denticity refers to the number of donor atoms A ligand uses to bind to a metal ion, while chelation involves multiple bonds stabilizing the compound. Crystal field theory describes how ligands affect the energy of d orbitals in transition metal complexes, leading to phenomena like color and magnetism.
Magnesium.
Chromatography
Hmm.
is a purification technique that separates the components of a mixture based on their interactions with a stationary phase and mobile phase.
Trimetry.
Titrimetric analysis of acids and bases. It's a quantitative analytical method used to determine the concentration of an unknown acid or base by reacting it with a titrant of known concentration. Lyophilic and lyophobic salts. Colloid systems where lyophilic salts are solvent attracting and stable, while lyophobic salts are solvent repelling and less stable. Detection of the functional groups in the organic compounds involves the chemical test to identify groups like hydroxyl, carbonyl, carboxyl, and amino groups in organic molecules. Cations in qualitative salt analysis. It involves identifying the positive ions like lead, copper, aluminum in a solution through chemical reactions, forming distinctive precipitates or color changes. Similarly, anions in the qualitative analysis, identifying the negative ions like chlorine, nitrate, sulfate, using the chemical reaction which may result in precipitates, color changes, or evolution. More salt preparation. The synthesis of ferrous ammonium sulfate, a double salt used in redox reactions, titrations for its stability. Potassium alum preparation. The synthesis of potassium aluminum sulfate used as a coagulant in various chemical industries. Iodoform preparation. A laboratory method to synthesize iodoform CHI3, chloroform CHCl3 like that.
Correct.
It has an antiseptic and a reagent in organic chemistry. Enthalpy of solution of copper sulfate. The heat absorbed or released when copper sulfate dissolves in water, demonstrating the exothermic or endothermic process.
What is uh,
Enthalpy of
what is
hmm?
exothermic and endothermic process? Can you give example?
Exothermic reaction means the heat will be liberated.
Ah.
Endothermic reaction means the heat will be absorbed.
Mm.
In the enthalpy of solution of copper sulfate, the heat absorbed or released when
Mm.
copper sulfate dissolves in water.
Mm.
Demonstrating exothermic or endothermic. Suppose if the temperature increases,
Mm.
it is an exothermic reaction. If the temperature decreases, endothermic reaction.
Mm.
The heat of change when an acid reacts with a base to form water, typically exothermic, measured in titrations of strong acids and bases.
Mm.
That is enthalpy of neutralization. Kinetic study of reactions. It investigates the rate and mechanism of chemical reactions, allowing the determination of reaction orders and rate constants. That is all about the kinetic studies.
Yes.
Markovnikov's rule. It states that in the addition of HX, hydrogen halide, halide may be fluorine, bromine, bromine, iodide,
Mm.
astatine,
Mm.
to an unsymmetrical alkene, the hydrogen attaches to the carbon with the most hydrogen atoms already attached.
Mm.
So whichever hydrogen has more hydrogen atoms, for that it will attach. While halide attach to the carbon with fewer hydrogen atoms. Hydrogen will attach to carbon atoms where more hydrogens are there.
Mm.
Where the halide attaches to the carbon with fewer hydrogen carbon atoms. That is Markovnich's rule. Peroxide effect is there, that is anti-Markovnich's rule. In the presence of peroxides, the addition of hydrogen bromide. HX means X is fluorine, bromine, bromine, iodine, astatine. It all applies. But for bromine, there is an exemption. In the
Okay.
presence of peroxides, the addition of HBr to alkenes follows the opposite of the Markov's rule. That is, where bromine attaches to the less substituted carbons. This is a anti-Markov rule. Ozonolysis of alkenes, a reaction where alkenes are cleaved using ozone, producing carbonyl compounds such as aldehydes and ketones. Polymerization of alkenes and alkynes, it is a process where small monomer units such as alkenes or alkynes join to form larger polymer chains. It's used in the manufacture of plastics.
Yes.
Electrophilic substitution in benzene, a reaction in which electrophile replaces hydrogen atom. Right.
On the benzene ring.
A reaction in which an electrophile replaces an hydrogen atom on the benzene ring, maintaining the
Aromaticity.
aromaticity of the compound. Then Friedel-Crafts alkylation and acylation, reactions in which an alkyl or acyl group is introduced to a benzene ring via an electrophilic substitution mechanism catalyzed by Lewis acids like aluminum
Chloride.
chloride. Just a minute.
Halogenation of alkanes.
Halogenation of the alkanes, the replacement of hydrogen atoms in alkanes with halogen atoms, typically occurring through a free radical mechanism. Sahars and Newman projections, methods used to visualize and represent the spatial arrangement of the atoms in a molecule, particularly for conformations of the alkanes.
Yes.
So there will be a change in the conformation, means change in the structure.
Yes. Homologous series.
Biomolecules in organic chemistry is series of organic compounds in the same functional group and similar chemical properties, differing by a CH2 group unit in their molecular formula.
What
They
is
are called as
CH2? What is the CH2 indicates, and what is the essence of CH2?
C
H2.
carbon is bonded with two hydrogens.
Yes, yes, that's what I'm saying. CH2, their molecule formula.
There
Okay.
will be a difference. The
Yeah.
CH2, 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 like that. There is a series.
Yes.
Then Clemenson and Wolf Kirchner reductions. So methods used to reduce carbonyl groups to alkanes, with Clemenson reduction using acidic conditions and Wolf Kirchner reduction using basic conditions.
Yes.
These are the reactions.
Yeah.
Cannizzaro reaction, it's a reaction where aldehydes without alpha hydrogen atoms undergo disproportionation to yield an alcohol and a carboxylic acid under basic conditions. Then aldol condensation is a reaction between aldehydes or ketones with alpha hydrogen atom to form beta hydroxyaldehydes or ketones, which can further undergo dehydration to give alpha beta unsaturated carbonyl compounds.
Can
That
you
is
give
aldol
example
condensation.
for ketones? What are we can call it as a
Ketone
ketones?
is C double bond O. That is a functional group.
Okay.
Acidic strength of carboxylic acids. The strength of carboxylic acid is influenced by the nature of the substrates, with electron withdrawing groups increasing the acidity and electron donating groups decreasing it. Acidic strength of that carbon dioxide, carboxylic acid like that. Grignard reagent, organomagnesium compounds used to form carbon-carbon bonds by attracting electrophilic carbon atoms useful in organic synthesis. Then nucleophilic addition to carbonyl compounds, a fundamental reaction where nucleophiles attack the electrophilic carbon of carbonyl group, forming addition products such as alcohols. Then anamines, iamines, nitrogen containing organic compounds formed from aldehydes or ketones, and amines, important
in organic synthesis.
So, haloform reaction is a chemical reaction where halogens like chlorine or iodine react with methyl ketones to form haloform and a carboxylate ion. That is haloform reaction.
Yeah, CH
Just like
start.
chloroform, iodoform like that, haloform.
Yes.
The qualitative determinant of haloform reaction is the concentration of halogens in the reaction. So the concentration of halogens in the reaction is determined by the
సార్ చెప్పండి. న్యూక్లియోఫిలిక్ 132.
అది నెట్ స్లో అయిపోయింది.
న్యూక్లియోఫిలిక్ అడిషన్ టు కార్బనైల్ కాంపౌండ్స్. ఇంకా ఓన్లీ జస్ట్ 4 స్లైడ్స్ ఉన్నాయి అంతే.
Shall we stop here?
No, 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 no. Please continue. The 10 minutes it takes. We will finish it.
Carbonic compound. It's a
Yeah.
quantitative analysis methods
Yeah.
to determine the percentage composition of these elements in a compound,
Correct.
which is essential for determining the empirical and molecular formulae.
Yes.
Formula is singular, formula is plural.
Correct.
Riemann-Tiemann reaction is a chemical reaction to form orthoformal phenols from phenols using chloroform and alkali, important in organic synthesis.
Correct.
Dehydration of the alcohols, a reaction where alcohols lose water to form alkenes,
Yes.
typically catalyzed by an acid and involving the formation of carbocations in the as intermediates. The mechanism of electrophilic addition to alkenes involves the formation of a carbocation intermediate when an electrophile adds to an alkene followed by the nucleophile attacking the carbocation.
Mm.
So that is the mechanism of electrophilic addition or alkene.
Mm.
Oxidation of alcohols to aldehydes and ketones. Primary alcohols can be oxidized to aldehydes and further to carboxylic acids, while secondary alcohols oxidize to ketones. This is the oxidation of alcohols and ketones. Mechanism of nucleophilic substitution in halogen compounds. It involves the substitution of halogen atom in a molecule by a nucleophile either through a one-step process, SN1, or two-step process, SN2 mechanism. So environmental effects of the DDT and FreeAds. These compounds widely used are known for their environmental hazards, including the ozone depletion, toxicity in the soil, DDT. Preparation and properties of aldehydes and ketones. These compounds are prepared through the oxidation of alcohols and are characterized by their carbonyl functional groups undergoing reactions like nucleophilic addition. Isomerism in hydrocarbons. Structural isomers have different arrangements of atoms, while stereoisomers differ in the spatial arrangements of atoms, important for the understanding the reactivity and properties of the hydrocarbon. Then the aromacity of the benzene, that is smell. Benzene stability arises from its delocalized pi electrons following Huckel's rule, making it resistant to addition reactions and more prone to substitution reactions. Instead of addition, they become substitution.
Yes. Yes. Colligative properties.
Properties and abnormal molar mass. Properties like boiling point elevation and freezing point temperature depend on the number of solute particles, and deviations from ideal behavior lead to abnormal molar masses. So ideal and non-ideal solutions. Ideal solutions follow Raoult's law exactly, where the intermolecular interactions are similar between solute and solvent, while non-ideal solutions deviate due to differing interactions. And Henry's law, it states that the amount of gas dissolved in the liquid is directly proportional to the partial pressure above the liquid and critical for the understanding gas solubility. Deviation from the Raoult's law. Non-ideal solutions show positive or negative deviations from Raoult's law due to the differences in intermolecular forces between solute and solvent. The critical temperature and pressure. The temperature and pressure above which a gas cannot be liquefied, no matter how much pressure is applied. So that is important in understanding the phase behavior of the gases.
Yeah.
So critical properties
Surface
are very important for any substance.
surface tension.
Surface tension is a property of liquids due to cohesive forces between the molecules at the surface, leading to minimal surface area, important for the capillary action and bubble formation. That is the reason any liquid drops will come form bubbles. So vapor pressure exerted by the vapor of a liquid in equilibrium with its liquid phase at a given temperature is important in phase transitions and colligative properties. Partial molar properties. These describe the change in the thermodynamic quantity when 1 mole of a component is added to a solution. It is important in solution thermodynamics. Freezing point depression and boiling point elevation. These are the colligative properties where freezing point of solution is lower and the boiling point is higher than that of the pure solvent due to solute presence. Electrochemical series. It's a list of elements ordered by standard electron potentials important for predicting the spontaneity of the redox reactions. Over potential. It is the extra voltage required to drive an electrochemical reaction faster than its equilibrium rate. It's relevant in electrolysis and battery technologies. Standard electrode potential. The potential difference between an electrode and its ion in solution under standard conditions crucial for understanding cell potentials. And in electrochemistry, Faraday's law for electrolysis will apply this law quantify the relationship between the amount of substance produced at an electrode and the quantity of electricity passed through an electrolyte. Gibbs energy and electromotive force. The relationship between Gibbs free energy of a cell reaction and its electromotive force determines the spontaneity of the electrochemical reactions. Then collision frequency in kinetic theory. The number of collisions that can occur per second in unit volume in a gas influence the reaction rates and transport properties.
Maxwell.
Maxwell-Boltzmann distribution law, it describes the distribution of speeds or energies among particles in a gas, funda- foundational for understanding molecular motions and reaction kinetics. So, old order and molecular reaction. The order is the sum of the exponents in the rate law, while the molecular refers to the number of reactants molecules involved in an elementary reaction. Transition state theory, it proposes that transition state is formed during the course of a reaction, helping to explain reaction rates and the effect of temperature on reaction speed. Isotopes and isotopes. Isotopes are atoms of same element with a different number of neutrons, while the isobars have the same mass number but are different elements, important in nuclear chemistry. Heisenberg principle, Schrodinger wave equation. Fundamental principles in quantum mechanics describing the behavior of the particles, the atomic scale, particularly the electrons. The principle of Michaelis formation. Micelles are, that is the clumps. Micelles form an aqueous solution of surfactants when the concentration exceeds a certain level. It is significant in colloidal chemistry. Critical micelle concentration, the concentration at which surfactant molecules spontaneously form micelles. It is important in understanding the detergent and biological membranes. Fermi level in semiconductors, the energy level at which the probability of finding an electron is 50%. It's important in semiconductor physics and material science. Band theory of solids. It explains the electrical conductivity of materials by describing the energy bands formed by overlapping atomic orbitals, distinguishing conductors, semiconductors, and insulators. The electron band theory. Energy levels based on either it is a conductor or a semiconductor or insulator, you can say. the coordination chemistry of transition metals. It explores the bonding and behavior of transition metals in complexes, including the crystal field stabilization and a ligand field theory. The activation and orientation in aromatic compounds. It describes how substituents influence the reactivity and position of further substitutions on an aromatic ring. It is important in electrophilic aromatic substitution. Hydrogenation and dehydrogenation reactions. Hydrogenation adds hydrogen to unsaturated hydrocarbons compounds, while dehydrogenation removes a hydrogen, both significant in industrial process. And carbohydrates, many sugars are optically active due to the presence of chiral centers influencing their physical properties and biological activities, like fructose and glucose. Both are same molecular formula, but there is different optical isomers. So enzyme catalysis, enzyme acts as a biological catalyst by lowering the activation energy of a reaction, following Michael Menten kinetics. Denaturation of the proteins, the disruption of protein structure by heat, pH change, or any other chemicals leading to a loss of function. It is critical in biochemistry.